Here we are starting with part 3, and we're taking a look at a picture here of Dr. Artemis Simopoulos. I would like you to know her. She is the founder here of the, what is this called? The Center for Genetics, Nutrition, and Health. You can look her up on Wikipedia. She's 87 years old now, having published 63 papers for this institution. More recently, she's doing meta-studies with thousands upon thousands of clinical cases and comparing them. So she's a research MD. That's her field. And she is the person who brought us Omega-3 way back in decades ago. And so let's pick up the action over here. And we're looking at her paper. You have this as a handout, as you recall. It's all about omega-3, and I picked this particular paper from her because she's comparing various nutrient intakes with disease states. We're looking for this ratio or better, omega-3 to omega-6 greater than or equal to 1. Now the way she frames it in this abstract, she's actually looking at omega-6 to omega-3. And she's noticing that in our current American diet, we're pretty much averaging 15 to 16 omega-6 to omega-3. Not very good ratio, not even close to 1 to 1. So one of the things that you need to be sort of bear in mind is that the body metabolizes both omega-3 and omega-6 as essential fatty acids. They're the only essential nutrients from the lipid category. And the situation with them is that if you read the literature, we have enzymes, particularly in the central nervous system, that are what we call promiscuous for omega-6. That is to say, they'll see omega-3 and omega-6, and they'll pick omega-6 to make the biosynthetic pathway. So you need to really provide those enzymes with equal amounts as much as possible of omega-3 and omega-6. 1 to 1 would be the ideal. And here she goes over a number of disease states. She says that in prevention of cardiovascular disease, a ratio of 4 to 1, 4 omega-6s to 1 omega-3, which is not close at all, but it's better than what we currently have. That was associated with a 70% reduction or decrease in total mortality. That's fairly profound. 2.5 omega-3 to 1, or omega-6 to 1 omega-3, again nowhere near 1 to 1, reduced rectal cell proliferation in patients with colorectal cancer. And then she notes that the 4 omega-6 to 1 omega-3 actually had no effect through these meta-studies that were looked at. So that's an important detail. We take a look here with women with breast cancer were benefited from the association of bringing the ratio closer to 1 to 1 with a reduced risk. And then we have 2 or 3 omega-6s to 1 omega-3. It says here suppresses inflammation in patients with rheumatoid arthritis, and the ratio of 5 omega-6s to 1 omega-3 had a beneficial effect on patients with asthma. And so these are important details, and I want you to go over that carefully. I want you to also notice the options that you have available to you. So these are actually now in the ratio of omega-3 to omega-6. These are whole foods, and you can look up the individual values of omega-3 versus omega-6 here. So that's available to you in milligrams, and you can see where large amounts can come from. But basically, if you just balance the rate, you're dealing with whole foods here, something that a supplement can't even begin to scratch the surface of. So if you have some small little tablet or pill that contains some fish oil, it's not going to do it for you because you've just eaten platefuls of food for your daily diet. So who are the heavy hitters here besides fish? And I want to set that aside. But fish, pretty much, you don't see poultry up here. You don't see beef or other red meats up here. You see fish. And then there's seaweed, because actually fish do not know how to make omega-3. I want to emphasize that. Fish are incapable of synthesizing omega-3. Where do they get it from? This is where they get it from. They get it from other fish that eat algae or seaweed or are otherwise vegetarians, right? So fish eat fish that eat omega-3. That's how they get it. I recommend that you do the same, right? If fish can do it, so can we. And there's seaweed. And then in more common foods, although this is not so uncommon, there's a lot of people who make seaweed soup. There's the possibility of using spinach. Okay, so here again, Popeye was right, as we've always suspected. There are certain condiments like sweet basil. There are fruits. Look at this. Very near the top is papaya. Not a bad deal. Generally, people are not heavily into turnips in the modern American public unless you have a garden of your own. Chinese broccoli, gailan, is a somewhat common feature. Cauliflower is definitely a heavy hitter. There's various types of seeds and beans. Not that many people are eating chia, but plenty of people are eating lettuce, broccoli, not so much turnip greens. Brussels sprouts, fairly common. And there's other things here. Take a look at kidney beans. Kidney beans are in a 1.5 to 1 ratio in favor of omega-3. And so if you were to combine your beans with your grains here, then, where was I? Then you would be having, actually be fixing your grains properly. So there's an awful lot of greens here. There's everything from butternut squash, summer squash, zucchini, snap green beans, kidney beans. Pinto beans are right here, a nice choice, and 1.4 to 1. And so we have quite a few things. Here's cantaloupe, navy beans, honeydew melons, eggs, since they don't have anything, are sort of not applicable. And then we come down to things that are more or less in the 1 to 1 range. But even if you're down here in the 0.7 or even 0.5 to 1, that's still better than check out the wild rice, the best grain there is. So rice in general is better. I didn't include wheat here because I'm, for one, allergic to wheat because of the gluten. I have that gene that makes me that particular way. And in general, people, even if they don't have the gene, are somewhat sensitive at times. Bananas are doing fairly well here at 0.58 to 1. So that's within the range of all the things that reduced inflammation, right? This entire front of the page here. I included things on the back of the page that are less than 1, way less than 1 to 1, so you can check that out. But I'm going to press on now to just the ideas here on your page 908. And the uses in the body would include the idea that you're storing nutrients, for one thing. You're storing calories. It's easier to store nutrients as fat because fat provides approximately 9 calories per 1 gram of fat compared to 4 calories for only 1 gram of protein or carbohydrate. So fat is the best way to travel with calories. Okay, so it is an important source of energy. We have what's needed to make phospholipid membrane components. We, of course, make certain other essential things like our hormones. Particularly, we make things like steroid hormones. And then there's the molecules considered important, like prostaglandins. Fatty deposits also function to protect certain parts of the body. So we'll pick it up in just a moment here to the next stage.